And beyond. This is day 13 of my DSA series. Today I'm going to be discussing question number 242, that's valid anagram. So let's dive right into the question. So the question states, given two strings s and t, return true if t is an anagram of s and return false otherwise. So what's an anagram? So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Let's repeat that definition once. So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Let's look at the test cases. So our first test case, s is equal to a n a g r a m and t is equal to n a g a r a m. Our output is true. Second test case, s is equal to rat, t is equal to car. Output is false. And the constraints given are s dot length and t dot length goes from 1 all the way up to 5 into 10 to the power 4. S and t consist of only lowercase English letters, and LeetCode has given a follow-up question that says, what if the inputs contain Unicode characters? How would you adapt the solution to such a case? So let's basically copy this first test case, and I'm going to explain how things work in this test case, and hopefully things will make sense to you. So if you didn't understand what an anagram is, I'll repeat the definition in simple terms. So two strings are said to be anagrams of one another if one string can be formed by rearranging the letters of another string, or from that we can conclude that two strings are said to be anagrams of each other if the frequency of all the letters occurring in one string is equal to the frequency of all the letters occurring in the second string. That is all that we need. Because if the frequency is equal, we can simply rearrange the letters and voila, we'll have the same string after doing this. So that's all we have to do. We basically have to use frequency. We have to count the frequency of frequency of elements in both s and t. If the frequency of all the elements are the same, then it's well and good, and we're good to go. If frequency of some of the elements differ, then we can say that they're not anagrams. That is all we have to do. And since the definition states that two strings are said to be anagrams if they're basically rearrangements of each other, a simple brute force approach you can think about is that why don't we just sort s and t? Because if we sort s and t and the frequency of all the elements are the same, when we traverse through s and t, we can basically say s would become equal to t, because if it's sorted on the basis of alphabets, we know that if the frequency of all the letters are the same, s would basically become equal to t. So that is pretty much the brute force approach. The only issue is that this is going to take log n time, because as we know, sorting in whatever algorithm you use, even if you use merge sort or if you use quick sort, it doesn't matter. It's always going to end up taking log n time. It's always going to end up taking log n time. So that is the brute force approach, but there must be a better approach. So whenever we think about frequency, something to keep in mind is we can either use an array or we can use a hash map. In most cases, we use a hash map, and that also answers the follow-up that we're going to use a hash map. And why do you use a hash map or dictionary? A hash map or dictionary basically stores a key value pair, so we're basically going to store the element and its frequency for both string s and string t, and if the hash map at the end of the day is the same, we can conclude that they're anagrams. So there are two methods in this. So the non-optimal one would be, well, let's maintain two different hash maps, one for s and one for t, that stores the frequency of all the elements, compare them. The only issue with this is that we'd have to maintain a ordered map, because they would be easier to compare. If we use an unordered map, you can't directly compare hash map because like the order of keys wouldn't be the same, right? So that is our first approach. And the second approach is we can just use a single hash map. We can fill it up once, and then we can try to cancel out letters. That is pretty much what we can do. We can try to cancel out letters, and if in the end the hash map only stores 0, we can say that all the letters got canceled out, meaning that the frequency of all the letters were the same. So let's look at a basic approach first. The basic hash map approach, where we're going to maintain two hash maps. So let's say this is our hash map. We start off with A. So A gets created, A's frequency is 1, then we come to N, N's frequency becomes 1, then we come to A is already there, so we increase this by 1, A's frequency becomes 2, then we come to G now, G is not present, G is now appeared over here, G's frequency becomes 1, then R comes in, R is not present, R's frequency becomes 1, then we encounter an A is already present, A's frequency becomes 3, M's not present, M's frequency becomes 1, so this is for S. And then we're going to do the same thing for T. So since its order is going to be in alphabetical order, I haven't maintained that, but for the time being, I'm just going to show the same order. So you come in over here, N, so N's frequency becomes 1, then we encounter A is not present, A's frequency becomes 1, then we come to a G, so G is not present, G's frequency becomes 1, then we encounter A's frequency becomes 2, then we encounter an R is not present, R's frequency becomes 1, then we encounter another A is present, A's frequency becomes 3, then we encounter an M's not present, M's frequency is 1. Then what we can do is we can have a pointer basically, or we can basically iterate through both of them at the same time. So we compare both of these. Are these the same? Yes. 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 So we're looking at keys and values both. And I just showed what happens in the background when we directly compare hash maps. So this is going to take, first of all, for the filling part or insertion in an ordered map takes log n, and then we take n time, big O of n time, just to traverse through it. So this is the case when we are maintaining two different hash maps. So instead of maintaining two hash maps, what we're going to do is we're just going to maintain one hash map, and we will try to basically subtract things. So yeah, that's the other approach that you can use. But in subtraction, the only thing like why we don't try to use that approach is because suppose n's not present. So what are we exactly subtracting? What are we exactly subtracting? That could be an issue, but it won't be an issue because like in hash maps by default the values are 0, so that's not going to be an issue. So suppose we constructed the hash map. Suppose we've constructed the hash map. So this is the hash map we got from S. Now what we're going to do is we're going to basically look into n. So we come to n first element, n's frequency becomes 0, we subtract 1, and then a's frequency basically becomes 2, then we encounter g's frequency becomes 0, then we encounter a's frequency becomes 1, we encounter r's frequency becomes 0, and we encounter another a over here, a's frequency becomes 0, then we encounter an m in the end, m's frequency becomes 0, all the values are 0, meaning that the frequency of all the elements is the same, so we can simply return true in this case that it is an anagram. Now the only problem is that this hash map, we end up using 2n space, you can say 2n space technique, that comes out to be big O of n because we're storing key value pairs, right? So if there are n entries, I'm going to store 2n things. And as we saw for a ordered hash map, it's going to take log n time for insertion. So better approach is we're going to use an array. And why can we use an array? In this question, it's given that the letters are all lowercase. So we can use an array, and to find that, we can basically do something like this. We can have an array. So let's say we have this array, and let's say it has some indexes. So this is the array that I'm talking about. Suppose we have an array like this of size 26. There are 26 lowercase alphabets, so on and so forth. Last index would basically be 25. So they can say that this is index 0, this is index 1, this is index 2, this is index 3. So index 0 would store the frequency of A. So over here it becomes 3. Index 1 would store frequency of B. So this would basically be B, this would be A, this would be C, this would be Z. That is all that we need. So now what we can do is we can basically fill it up according to S, subtract using T. And if all the values are 0, that basically means that it is an anagram because the frequency of all the elements becomes the same. And how would you do that if you're not really sure? We can use something like ASCII code. So in C++ and other programming languages, they can do something like this, A minus A. This would basically subtract the ASCII code of both of them. This becomes 0. And then if we do something like B minus A, ASCII code subtraction becomes 1 because their difference is 1. So using this, we can get the index, and then we can add or subtract. That is the main logic we're going to use. So I'm going to show this approach. The other approaches you can try on your own, and if you face difficulty, you can drop down comments. So what I'm saying is, in this case, first of all, we check if s.size, if it's not equal to t.size, we know that they cannot be anagrams because the frequency of elements will be different since the size is different. So it cannot be a case where the frequency of all the elements would become the same. So if we say s.size is not equal to t.size, when it is not equal to t.size, we can return false. So this was the first case I was talking about. Now after that, what we're doing is we're taking a vector. We can take a vector of int. Size of it becomes 26, 0. Now what we're going to do is we're basically going to traverse through s. For int I is equal to 0, size is an s.size. Since the size of s and t are the same, we can do this. We can either do t.size or s.size. So we're basically going for s, we're going to add 1 to the frequency of that element, and for t, we're going to subtract because we're basically canceling out elements. That's the basic logic that we're using in this question. So it's simple. We're just going to do v of now index. It would basically be s of y. That would be the current character. Current character minus a would get us the index, and we're going to do plus plus, and then v of t of y minus a minus, and then we can basically go something like for int I is equal to 0, I is less than 26, I plus plus. We're basically going through the entire frequency vector. If v of I is not equal to 0, we can return false. And if we come out of this loop, that means that all the values are 0. Now we can end up returning true, and that is our approach. So we first compare size. If the size is different, we know frequencies can't be the same. It's going to have to be false. Then we take a vector of size 26, we traverse to S and T, their size is the same. S, we're basically adding 1 to frequency, and T, we're subtracting 1 from frequency. We then traverse through our vector, and if its value is not equal to 0 at some point, we know that there must be a difference in frequency of a given element. We return false, and this, if this loop runs to completion, we can say that the frequency of all the elements are the same. That's why all the values in our vector or array, they turn out to be 0, concluding that the frequency of elements are the same. So it's the best approach. It's basically it's going to take big O of n time and big O of 1 space. So that is the main difference. It's going to take big O of 1 space because we know that vector size is always going to be 26. So I have mentioned some of the other approaches. So this was a sorting approach, log n time, and then we can have a hash map. So this is what we did in the hash map. Same approach, nothing different. We just took a hash map, added 1 from frequency, subtracted 1 from frequency. We check n.second, that's basically the value. We did the exact same thing. This is just taking a bit more space. And since we are dealing with lowercase letters, we can just take an array. So you should probably know this down somewhere, that we can take when we can take an array. And hopefully things did make sense. So thank you so much for tuning in. Stay tuned for more videos. Thank you so much. Au revoir.